In this part of the course, we are going to talk about some simple arithmetic, addition, subtraction, multiplication, etc., and how we can provide input to our programs, not just by typing in some variable values and calculating over them, but also we can interact with the user so that we can run our program on different input from the user. Also, we are going to discuss about file operations, how we can open files, create files, and add data to those files and read data from the files. So let's begin. Before we start, we should discuss about the operators defined in as mathematical operators defined in Python language. They are actually straightforward. The general purpose operators are valid, which are addition, subtraction, multiplication, and division. For multiplication, you would recall that we don't use the X sign or dot sign, but we use the star symbol, the asterisk operator you can find on your keyboard. And there is an extra modulus operator which calculates the remainder of an operation, remainder of a division operation. So in this example here, you can see that 11 mod 5 is 1, because when we divide 11 by 5, we'll get a remainder of 1. Floor division is obtaining an integer value out of a floating point or decimal point division. So when we divide 9 by 2 in a regular division, we would normally get 4.5, but in a floor division we get 4.0, truncating the decimal part. And for power operations, raising a number to a specific power, 2 to the power 3 is 8. So we achieve this by using two star symbols side by side without any spaces in between those operators. So in our clear this. Okay, if we type 1 plus 2 in our Python terminal, let me bring up 1. So if I type Python, well, it's asking for this installation again, although I have already installed it. Let me find you another Python interpreter here, or let's just open a example file. So if we type print 1 plus 2, correcting the print, and if we run this program, it's going to calculate the result of this addition, which is 1.2, and display the result. So in order to have this print function working, we would first have to obtain the necessary data, which is going to pass to the print function. So our program first makes a calculation inside the parentheses of the print function, and as soon as it obtains 3, Python invokes this print function to include to output the value 3. So it first tries to obtain the result of the operation, and then it proceeds to output the result. So you can see these examples and experiment them on your code. Please do. It's important that you get used to these operators. So there are some distinctions between Python versions where they would behave differently in floor division and division especially. So you might end up with some integer result or a floating point result depending on the version you are currently using. You are now using Python version 3, that's okay, but as I told you earlier, in your working career, or if you end up maintaining some software code, you might encounter some programs written in older versions of Python or older versions of Java, etc., which you might have to maintain. So if you happen to end up at such a situation, you should go back and check the specifications on those operations or on those functions, keywords, etc. Just a reminder that you should keep in mind. And we have this example for you that you can run to output the operation results. And there's a specific type of error that you should be aware of. If you try to divide a number by 0, the result is inconclusive. So the computer programs usually crash when they happen to divide some number by 0. We don't do it on purpose. We might be dividing a variable by another variable. So the divisor might have this 0 value. So if that happens, the program might crash. In order to prevent your program from crashing, you should take precaution that keeping in mind that at some point your variable might receive a 0 value. You would either check it before the division and act accordingly, or you might simply raise an error that you can control yourself. If you leave that error unattended, your program is going to crash most likely. But if you don't, if you take the precautions, handle the error, potential error, then your program is going to be able to warn the user or take other measures to prevent the program from crashing. A program crash is usually termination of the program itself, or it might end up in some serious damage. There are some catastrophic events in software history that actually didn't end up very nice. There might be casualties as well. So programming is a serious job when you come to the point that your code is affecting the life of other people. If you are writing software for an airplane, you would understand what this means. Or you could be writing software for a medical appliance. So these should all be taken care of. You shouldn't be rushing. You shouldn't be allowing anyone to rush you. So each line of your code should be inspected carefully, depending on the risk level that you are working in. There's a Python console on your PyCharm application that you can use to make calculations. That was my mistake. can simply calculate these values. When it comes to the floor division, dividing 9 by 2 is going to generate 4.5. But in case of the floor division, the result is going to be 4 as an integer value. If we divide 9.0, which is a decimal number, by 2, the result is going to be a floating number as well. This might be important to you. So we have this example, such as A is, print the type of the result or type of the calculation, which is 9 floor divided by 2. You're going to obtain an integer type. But if you divide and obtain the result of a decimal number divided by floor divided by 2, you're going to receive a floating point number. So the type of the variable might be important to you. In that case, you would consider that the floor division acts according to the operands it receives. If it receives the both operands to be integers, this result is also going to be an integer. For Python 3 I'm talking. It might be different for other versions. So you can use this Python console as well for your outputs. If you say type 9 divided by 2, scrolled up too much. Okay, now it's turned into read-only. Let me clear this. Clear all. Clear all. Okay. Okay, I started it once again. Type 9 floor divided by 2. It hasn't displayed anything. I should be typing it into a print function. 2.0. Type of 9 divided by 2. Okay, now we see that the class of that calculation, which is an integer, type 9 divided by 2.0. Now we obtain the class as the floating point number. So the representation of these numbers are different in the computer's memory. This is why we need to be careful about which number we are using. The same amount of memory space may be used both for integer and floating point number. But if you are working with a floating point number stored in the same amount of memory, the whole part of that floating point number, the capacity of the whole part of the floating point number will be much less than the integer or the long number. So these are some details that you should keep in mind when you are coding some precise calculations in your application. Also, we have this example source file for you that you can open and execute right away and see the type of each calculation as well. Okay, some of these codes are ready here because I'm re-recording this session because of that voice problem I had in the earlier recording. So these are all already typed in for you, but most of them are consistent with the source course content we have here. So this Celsius to Fahrenheit conversion, as you know, is multiplying the Celsius temperature with 9 and dividing the result by 5 and adding a 32 to the multiplication and division result. And if we define a function for it, Celsius to Fahrenheit, it's going to receive a Celsius value, 22, or other values if you like. Let's find this function, home, copy. Okay, let's copy this and call our function for another value, 26, and maybe 36. When we execute it for each line, we receive 71.6, 78.8, 96.8. So in each line, we provide a value to the Celsius variable. So we have defined our function to be Celsius to Fahrenheit. The naming is not important, but it should give a clue about what this function is performing. It receives a variable, you can call it var c or variable Celsius or whatever you want. But it has to be consistent in your application, so I modified it. I should also change this variable Celsius, so they are same. Whenever I pass this 22 value to my function, it's going to replace variable Celsius as 22 and use that 22 to multiply it with 9, divide by 5, and add 32 to the result. The function is going to calculate this part first and then return the calculation result to the print function where it was called initially. And the same is going to happen in this line, similarly on the third line as well. So we're having these results output by the print function, not the return itself, but the print function makes the outputting. Return is used for providing this value, sending this value back to the calling statement, which is this part of the code. And the other function is calculating the Celsius value from the Fahrenheit, which I have here. So this is Fahrenheit to Celsius that we transformed our calculation to be the reverse of the Celsius to Fahrenheit function. And when we run this, we're going to see something interesting, that calculating Fahrenheit to Celsius value of 71.6 does not give 22 as a result. This is due to the fact that our computers might not handle floating point arithmetic as precise as we would expect. So if you are dealing with some serious data such as monetary transactions or a cosmic calculation for a very distant coordinate, you would normally use more sophisticated libraries for such precise calculations. Also, if you are programming an onboard flight computer of a fighter jet or a passenger jet, you would not be relying on such general purpose arithmetic libraries as we use in our examples. So it's very important for even for the slightest amount of change, 1 millionth of a second, the result might change. So the calculation has to be very precise, and you wouldn't normally rely on such mistakes that you would normally tolerate in your approximations. But if you need such a precise calculation, you would have to use those special libraries in your application. So this is not a calculation error, but it's just a matter of precision, that the amount of floating points numbers that you can store in the provided memory of your computer. It's just a number, but the representation makes things hard to process for the computer in such a precision. This is due to the fact that our numbers, decimal numbers, are converted into binary form, and the amount of binary digits allocated for a floating point is limited. So we don't have infinite number of decimal places, decimal numbers reserved for our numbers. This is why the calculation is different than expected. When you're making calculations, the order of operands and the precedence of operands is similar to mathematics. Multiplication and division have higher precedence than addition and subtraction. Also, the parentheses have higher precedence. Fix this. Parentheses have higher precedence than multiplication or division. So first the program calculates the inside of these parentheses, obtains 8, and going from left to right, okay, it doesn't divide 8 by 8 and multiply by 2. It starts from left to right, multiplies these 2 times 8, divides it by 8. Okay, it obtains the value 2 and subtracts 1 at the final stage. But if you want our denominator to be evaluated first, then we can simply use the parentheses as in this example. This doesn't make much sense, but when you are using variables in your program, you would see that a variable a might contain the value 8, and you might be using that variable and calculate the result accordingly. These variable values will not be typed in, generally will not be typed in by the developers, by you, but they might be received as parameters to some functions, or they might be input by the user during your application's execution.